Now, there are several different ways to run large language models locally on your PC. So all the computing happens on your PC, nothing gets sent up to the cloud. And one of them is LM Studio. Now, LM Studio has just announced a new variation of LM Studio called LM Studio Bionic. And the difference is that Bionic has built-in Agentic capability, so that means coding and working with files locally on your PC. It's available for Windows only at the moment. So in this video I want to show you Bionic on Windows and what you can do with it. So if you want to find out more, please let me explain. Okay, the place to start is the lmstudio.ai website, and here you can see in big bold letters Meet Bionic. The old version of LM Studio is still available, however this is now front and center. It's only available for Windows at the moment. Hit the download button and then install it. Okay, once it's installed, this is what you get. So in the middle here we have our normal chat prompt box. You can also attach things to the prompt. Here is where you select the model, and over here on the left hand side you can manage your projects. Okay, the first thing you need to do is download a model, and so you click on here and then get local models, and lots of different ones here to choose from. You can search, there's lots of stuff, there's a recommended list, there's the one that's had the most downloads, you know, all this stuff. Now we'll start with that Gemma 4 12 billion one, so I'm just going to hit the download button, 7GB download. Now while we're waiting for that to download, it's worth mentioning, of course, local LLM runs better when you have a good graphics card. It will run technically if you've got just a CPU, but it's going to be very slow. If you've got a good graphics card, then it's going to run faster, and it depends how much VRAM you've got. So as you can see here, this is a 7GB download, so it might fit in 8GB of VRAM. You can pick smaller models if you don't have that much VRAM. Remember, the smaller the model, the less capable it is. It's also worth noticing this green ticket here, which tells you that this model can be offloaded fully to my GPU. If that isn't there, then you're going to have to look at the size and things. Anyway, it's now come up and it says use in new chat. So let's go and do that. Okay, so you can just treat this like you would treat any LLM. Here's a chat window. Ask it a simple question. What is the capital of France? It goes ahead and it loads up the model, and then it gives us an answer. The capital of France is Paris. Great. Well, this is what you can do with, you know, LM Studio and llama and other things. But let's try something a bit more interesting. Let's go now to a new project. We're going to call it Primes. I need to choose a folder for it. Okay, and I've got a folder called Primes. Let's go ahead and do that. Now, the thing about Bionic is it's got agent coding built into it directly here. This is all local, nothing gets uploaded onto the internet. Now, if you open up this sidebar to the right, you can now see that I've got this primes folder and then there are no files in it. But that's this gives me a view of what's being created in the folder. So let's ask it a coding question. Write a highly efficient C program to find the first million prime numbers using a sieve. Okay, nothing too difficult. Should be able to do this in a few lines. Go. Now, it's worth mentioning at this point, I also have GCC installed here on this Windows PC, and I also have Make installed. Now you can see it's running away, and over here on the right hand side we've now got a primes.c, that's the source code, and a primes.exe. So it's been compiling it and it's running it to make sure that it works. Okay, now it's starting to give me the answer. It's giving me the full explanation of what it's doing. It's actually also giving me the source code here, telling me how to compile it and then how to run it. Okay, so open a terminal and look in there. There you can see primes.c, and let's run primes.exe. Okay, and it very quickly told me what the millionth one that it found was, and the total it found was 1 million. So there you go. Now that's not too much of a complicated project. As you can see, not that many lines of code. Let's try something a bit more complex. Okay, so we'll go with new project, and we're going to go with ASN1 alternative, and I'm going to pick a folder, and we hit create. Okay, the question now this time is this: create the specification for a simple encoding method similar to the abstract syntax notation ASN1 or to protocol buffers. That's by Google. The scheme must use a simple type length value encoding with support for primitive data types, including int8, int16, and so on. The encoding is flat and can't include sub-objects. Make the specification detailed and useful for a programmer to implement the scheme in any programming language. So this is just the specification. And again, just to repeat, this is local, running on that Gemma 4 12 billion parameter model here on my PC. Okay, so it's come up with a plan, 6 steps, and it's starting to do it now. And as you can see over here on the right hand side, I've got this specification file, markdown file, that is starting to be created. It's not finished yet. So again, we can see the files that are being created in the folder that we assign to each project. Okay, so I'm going to go ahead and say implement that specification file in C. So I'm just going to tell it to go ahead and do it according to the specification that it's created. And as before, it's creating files. Already we have a C file and a H file. Okay, and it's finally finished that. And as you can see, we've got some files here in the directory. There's a test program as well, gives me all the explanation. And so that's great. And now if we look in the directory, we can see there's a test file, so let's run that. It tells me that the little suite of tests that it's built have all passed. Now the key to all of this is the model that you use, which is dependent on what hardware you have. The better the graphics card with more VRAM, then the bigger model you can run. Now I did a whole video on comparing different types of local models and seeing if you could use them for complex coding tasks. And really, Bionic fails exactly the same way as OpenCode fails, or as Claude Code fails when running locally on a PC. It depends on the model. So for example, using the best model I could run on an RTX 5090, that's 32 gigabytes of VRAM, I still came into this same problem when developing my new Scrippy project. And I cover all of this in that other video, but new Scrippy is basically a language interpreter. I define the language and say to the AI model, go ahead and write the interpreter for this model. Now they all succeed to a point. They can actually kind of understand the language, they can start the interpretation, but it's got some holes in it, it's got some bugs in it, it's got memory leaks in it, it's got things like that. And so Bionic, running the biggest local language model I could, runs into exactly the same problem. So again, it's not the harness in this case, it is the model. However, for smaller tasks, like I showed you, smaller projects, couple of thousand lines maybe, it's going to do absolutely fine. So do go and give it a try and let me know in the comments below what you think about it. Okay, that's it. I'll see you in the next one.